Okay guys, in today's video, I am going to talk about one of the sexiest, most awesome things that goes in a house that you really want to know about, and that is septic systems. Okay, I'm being facetious, but with that said, I have been involved with a lot of builds over the years where we have installed septic systems. I came up through this industry working for a company that was a developer of 1 and 2 acre lots out in the county area where every home had to have a septic system, and we built homes in those neighborhoods. So from the time I was in my 20s till now in my, let's just say, mid 50s, I am still building homes with septic systems because all we do are build on owners' lots and land, and a lot of times it is land. It is property that is in an area where there is no sewer system. So in today's video, I know it may not seem like the coolest cabinets or tile or the latest features that you can do in your home, but I'm going to talk about something that's pretty important because a lot of the people we build for need these things. And so far, after 30 plus years, I have never met a homeowner that understood what they were or how they worked. So in this video, I'm going to give you the 101, a comprehensive breakdown on septic systems. Okay, so let's start with what is a septic system and why would you need one? A septic system is just simply a private water treatment, I should say sewage treatment plant for your home. So all the waste that leaves your house out of the main drain we call a sewer exit will go into a septic system, will be processed and disposed. Why would you need a septic system? You would need a septic system if you are in an area that does not have the ability to hook up to a sewer system. When I talk about sewer systems, I'm talking about what you see in the city environments where you have a lot of infrastructure, including city sewer systems that, in that case, every sewer exit that leaves a house has a pipe that goes to the sewer main. The sewer runs away and it gets treated in a big waste treatment plant. But when you can't hook up to when you cannot hook up, I'm leaving that in. When you cannot hook up to a city sewer system, you have to have a septic system. And there are all kinds of properties that don't have the ability to hook up to city sewer. There are lots in the city where there is no sewer in that given neighborhood, and so people have to use septic systems. I know I've been in that situation before. So that is why you would need a septic system. Now I'm going to talk about what they are. This right here is a septic system. Now, all you're seeing are the tanks. The rocks around it are just so nobody hits it. Interestingly, we are on a commercial project, not a residential house, and it uses septic systems also. So this is what it looks like on the top, but I'm going to talk to you about what they are and the types available for you to use. Okay, so now you know that a septic system is just a private sewage treatment plant and that you will need one if you do not have the ability to hook up to a city sewer system. Now I'm going to talk about the two main types of septic systems that are available, the history of them, and kind of how we got to the point that we're primarily using the one that we are. So first, let's back up and let me give you a little history lesson. As you can imagine, humans have been dealing with their, shall we say, organic waste as long as they've been around. And when humans started to kind of coalesce and create cities and civilizations, getting rid of this waste became a big problem. Surprisingly, it was a big problem until not that many years ago, roughly 150 or so years ago, actually less than that, with the disposal of sewer waste. Leading up through the ages, there were some very smart people that thousands of years ago created sewer systems. You had in ancient Middle East, in Rome, all these places, they created ways to take the sewer away from where they lived. That was great. What they didn't have was a way to process the sewage. So what these sewer systems actually did was they took everything and they dumped it in a river, in bodies of water, in the ocean. And as you can imagine, that isn't a perfect solution. Millions of people have died throughout time from diseases as a result of all the bacteria in the waste that have been put into rivers and all these other places. So this has been a real problem throughout human history. Interestingly, the first modern sewer system in a big city was in London in the 1860s. But they were still taking the waste, dumping it in the Thames during high tide, thinking that the low tide would pull it away and there wouldn't be any problems, but they did have problems. So eventually, at the turn of the century, around 1900, they started figuring out how to process waste. Interestingly enough, in 1860, a Frenchman designed his own concrete tank at his house, ran a clay tile pipe out to it, and had all of his sewer going into this tank for a decade before he opened it up and verified that it was actually breaking down waste rather well, and he patented it, and it became the first and what is still a commonly used septic system all these years later. So for roughly 150 years, we have been using a type of septic system that was invented in France in 1860. Okay, so the modern type of septic system was invented all the way back in the 1860s, became in widespread use in the late 1800s, both in Britain, in America, obviously in France where it was invented. And one of those types of systems, the one that was invented by this Frenchman, is still being used today. And that is a system commonly called conventional septic system or sometimes leach field system. But the technical term is an anaerobic septic system. Anaerobic means without oxygen. So the way an anaerobic septic system works is the sewer pipe from your house is hooked up to a tank. That tank has anaerobic bacteria in it that are breaking down the organic waste. So this type of bacteria does not need oxygen to live. Matter of fact, it lives on things like sulfur, carbon dioxide, and it creates a fermentation process breaking down the waste until the waste is broken down to something we call effluent. Now, when you think about a septic system and everything that runs down the drains of your house, the primary thing that goes down the drains of your house is water, right? Water from your sinks, water from your shower, water from your dishwasher, your clothes washer. Obviously, some of that has soap in it and things of this nature. There's the stuff that goes down your toilet. But in the end, what goes into that septic system is probably more water than anything from a ratio standpoint, but it does have the organic solids in it. It can have food from your garbage disposal and dishwasher, things like that. So this bacteria is breaking all of that stuff down to what they call the effluent, which is the processed fluid that's left over. Now, the way these types of septic systems, the anaerobic septic systems, dispose of the effluent is a pipe leaves the tank that the effluent goes out of, and that pipe goes out into the yard where they have dug a lot of trenches. They have laid gravel in these trenches. That pipe turns into a perforated type of pipe. Gravel is put back over the pipe. It's all covered back over. You can have what we call a drain field or a leach field in your yard, and that effluent is constantly leaching into the ground. Now, it's done that way because effluent is not actually safe. It's broken down so far, processed to a point, but it still has disease-causing bacteria in it. Cholera, things like that can be caught from effluent that comes out of a septic tank. So what's happening is as it is leaching into the ground, the water is slowly filtering down, and the ground is a filtration system. Not many people know that, but think of the earth as one big charcoal filter. The water deposits that we pull out of the ground from water wells, what we call underground aquifers, is naturally purified water. If you think about an aquifer being 300 feet down, that water generally started on the surface, somewhere on the surface, and it ran through the sand and rocks until it got to an area where it remains in an aquifer. That has been filtered as it goes through all that sand and rocks. So that's what a leach field system is doing. It is taking that effluent, it is filtering out all the bacteria and things. The remaining water just trickles down until it is in an underground aquifer or trapped in some area down there. So that's how a leach field system works. Okay, so there's a second type of septic system, and it is way more common, at least in these parts of Dallas-Fort Worth, and I would imagine across the country. I'm going to do a little investigation about that, but around here, ever since I first saw a septic tank, we have been doing what we call aerobic septic systems. So you'll notice the first one, the conventional, is called anaerobic, meaning no oxygen. An aerobic system means oxygen. It uses the same processes of bacteria to break down the organic waste, but it's using a different bacteria. It's using a bacteria that thrives on oxygen. So much so that one thing that aerobic septic systems have in them is something called an aerator, just an air pump. Think about a fish tank that has that pump that's always pumping air into the water. That's to oxygenate the water so the fish can breathe. Same concept with an aerobic tank. That tank I showed at the beginning here with the green lids is an aerobic septic tank. The aerators continually pump air into the tank, which causes the aerobic bacteria to thrive and break down all the waste. Now, the positives of aerobic septic systems is aerobic bacteria are significantly better at breaking down waste. So they break it down further or process it further. They can process more waste faster. So an aerobic septic system does a better job at processing all the organic solids that go into the tank. Now, how does an aerobic septic system dispose of the sewer? Well, it's not a leach field type of system. What an aerobic system does is, as these solids are being broken down into effluent, it ends up in a final tank. And there is also a pump in that tank, but it is what you would think of as like a water pump. It is designed that when the effluent hits a level in that tank that kicks on a sensor or a float sensor, that pump cranks on and it pushes the effluent out and actually sprays it through sprinkler heads on your yard. Now, there are a few types where you may have a drain field in the ground. It's not a leach field. It's still that pump kicking on and just putting the water into the ground. But most of them are above ground discharge. There's literally a sprinkler system line that leaves the tank goes out to 2 or 3 sprinkler heads. And so those sprinkler heads run when the pump tank's running. In that pump tank are some sanitizing tablets. Think of something like the tablets you put in a swimming pool. And what these are doing is killing any remaining bacteria in that effluent. So to begin with, the aerobic bacteria break down this effluent much further, process it much further. It's much cleaner effluent than with an anaerobic system, a conventional system. But on top of that, there's some sanitizing of that so that the water is technically clean. The environmental regulation authorities would not allow this stuff to be sprayed on your yard if it were dangerous. So I've always told my customers, do not do it, but theoretically you could stick your face down in front of that sprinkler when it's going and you're fine, because that is clean water, clean effluent that's coming out of those sprinkler heads. So why did we start using those kind of septic systems, the aerobic versus the anaerobic? Well, first let me say anaerobic systems are still in use. They are still a common system, but around here they have generally been replaced by the aerobic systems. Through time, as environmental regulations got stricter and scientists learned more about the environment, they realized that leach field systems did present problems. So from a health standpoint, again, the effluent coming out of those pipes in the leach field is not safe. And should you have some kind of situation where it is allowed to come to the surface, that could be a problem and cause sickness and diseases. You could have a situation where it somehow contaminates a water table. That's no good if you're pulling water out of that water table with water wells. And so what they were looking for was a way to really process and dispose of the effluent. And that's why the aerobic system was invented. Again, if you think about it, it takes everything that goes down your drain, processes it, and spits it out some sprinkler heads, and it's completely safe. So it is a completely processed sewer plant at that point. So the aerobic systems have become the common thing around here. Now in Dallas-Fort Worth, if you've watched my other videos about foundations and all that, we have a lot of high clay content soil, so that doesn't absorb water good. We have a lot of rock. We even have shallow water tables. So the leach field systems are not always the best fit for some of the situations we have here. I'm building a house on a lot now that is going to get a septic system, but it is the sandiest soil I've ever built on. I guarantee you if that homeowner wanted a leach field system, we could probably do it. You do have to do a test of your soil called a perk test, which just verifies that the soil can absorb and filter the effluent. But when you have sand and that type of material, that's usually going to be good for a leach field. If you're over here with rock and clay and it can't absorb it, you don't want a leach field, and you will have to use an aerobic septic system. So those are the primary reasons that things have swung from the conventional anaerobic system to the modern day aerobic systems. But there again, you can still use an anaerobic system if you want. So why should you use one system over another? What are the pros and cons of each? I'm going to go through that now. With the anaerobic system, again, the system that has been around for 150 years, that is just a concrete tank that uses anaerobic bacteria to break everything down, and then it goes out through a leach field. On the positives, those are the least expensive options. They're significantly less than an aerobic system. The second positive, I would say, is they are a set and forget type of situation. They are what I would call a dumb system. It's a concrete tank with a drain field. You don't have to do anything to it. There are no pumps. There's nothing mechanical going on, so there should be nothing to ever have to deal with the exception of organic material over time doesn't get completely broken down. There will be a sludge that accumulates, and you do need to get it pumped. Generally, they say every 3 to 5 years. I've known people that have gone way longer than that. But regular pumping every 3 to 5 years is pretty typical. That's not very expensive. I mean, you're talking usually under $1,000 to pump a tank, and it may be something you're doing every 5 years. So from a kind of durability standpoint, let me talk about lifespan last. Concrete tank, somewhat indefinite lifespan when you think about it. I mean, short of the ground really starting to move and causing some stress on the tank, that should remain good for decades. The failure point with those is going to be the leach field, but even most leach fields are going to see 20, 30, 40 years. So generally speaking, the durability, the lifespan is decades with the anaerobic tank. What are the negatives and reasons you might not want to use an anaerobic or a leach field system? Well, like I said, you may have soil that just, you can't do that type of system. So that takes you right out of the running. Let's say you can do that type of system. You've got soil that percolates well enough. The downsides would be, again, the tank itself, no brainer, concrete tank. Both of these have concrete tanks. The leach field is the failure point. So the drain field. You could have, well, you've got a few different situations. The one everybody worries about and everybody hears about is sewer systems backing up into the house. This can happen with an anaerobic system because it is emptying itself out in your yard or your land through that drain field, through that perforated pipe. If you had enough, big enough rains, long enough rains where the ground becomes saturated, it can no longer leach into the ground. And that's what causes those systems to back up. Either a complete failure of the pipe, maybe the pipe has been crushed and it can't drain out, or the ground has become so saturated that it just cannot drain. So you're putting water down your drains, it has nowhere to go, it eventually comes back. I just mentioned, crushing a pipe. That's another downside. The leach fields are permanent. Permanent in that you're never really gonna mess with those things, but they could fail. If somebody's driving vehicles over them, you can crush pipes, you can have clogs of those things over time with some of the organic sludge that builds up. And there's no great fix if your leach field fails other than to get in there and dig it all up and really redo it all, which is a pretty invasive process. So that's kind of the pros and cons of the anaerobic or conventional leach field system. Okay, so what are the pros and cons? Why would you want an aerobic system instead of an anaerobic system? The aerobic system, the first positive I'll say is that the drain field is not permanent, okay? Again, concrete tank, That's probably good for decades. The drain field is a sprinkler line that goes out to a couple sprinkler heads, and it's not what we think of as permanent. We have all seen sprinkler lines. They're all of 6 or 8 inches in the ground. I have come back on some of these homes with aerobic septic systems and done guest houses, ADUs, accessory dwelling units, this kind of stuff. And we've just moved those things. Hey, they were in the way. We needed to move them. When they're first put in, they're engineered and designed to be in a specific area. But if you're going to come in and later do a pool or a guest house or something like that, and the thing needs to move, it's easy to move. You literally get your sprinkler or irrigation person to move it because it's the same thing they work with every day. So from that standpoint, the drain field itself is very easy to deal with. The fact that you do not have any type of biohazard at all as far as what's coming out of that is also an advantage. Again, that is clean effluent. I just call it water at that point because that's what it is coming out of those sprinkler heads. So a very safe system, and that's why they're in wide use. Now, why might you not want to have an aerobic system? Cost would be the first one. They are more expensive than the anaerobic or the conventional septic systems. For some perspective, and I hate to throw out numbers in these kind of videos because it really depends on the size of the system, but generally you could probably get an average anaerobic system anywhere from, let's say, $6,000 to $10,000. An aerobic system, you may be in the $12,000 to $16,000 range, depending again on the size of the system. They do have different tank sizes and things like that. Your durability, or I guess failure points with those are twofold. You do have mechanical things going on. Anybody that has been around a car, any kind of electric motor, whatever, they don't last forever, right? Mechanical things wear out and break down. In the case of an aerobic tank, that aerator is running 24/7, just like that fish tank pump. It is constantly running. So it is going to fail first. I think they say most of those are expected to last 5 to 8 years. So it is actually something you will have to deal with eventually. And this is the kind of thing that a lot of people don't know about. What do you mean I thought the thing ran forever? Well, nope, it's a mechanical item. It's not going to last forever. You can have the same kind of issue with the pump tank motor. It could fail at some point. I hear less about pump tank motors failing. They don't run as much. You think about they're only turning on when that tank's getting full. That tank's only getting full subject to how much water you're running through the house. You could have a couple living in a house that don't use a lot of water and their septic system's not going to run that much, or their pump tank isn't going to pump that much. On the flip side, you could have a family of 5 with all kinds of stuff going on all the time with showers and clothes washing and all that, and it will run more. So the concrete tank itself, decades. The pumps will fail over time. On the positive side, a septic company can repair those in a day and you're moving on back down the road with those. So those are the main pros and cons. Again, depending on the area that you're in, you may have to use an aerobic system. If you want to use the other type, the county health department, which is who deals with things in our area or in Texas, will require a percolation test on the soil to make sure it can handle it. So those are the main reasons you might want one system over another. Okay, so I know this wasn't the incredibly intriguing, sexy finish out, what's the latest home automation and things like that. I'm talking about sewer treatment and septic systems. But I hope for some of you out there that are having houses built that have a septic, maybe you're going to build one that needs a septic, maybe you own a house that has a septic and you don't know anything about it. The point I'm trying to make here is a little bit of education on these things of your house that nobody understands, because at some point when you have a problem with it, now you're going to be a little flummoxed about, what do you mean my aerator pump broke on my aerobic septic system? So hopefully this video has helped kind of educate you a little bit. I appreciate you guys always as watching. I will do those videos soon on the really cool interior stuff of houses. So remember, stay tuned for the next one.